In this section, we're going to discuss the periodic table. The periodic table of elements is one of the most useful tools ever created by humans. But why is it called the periodic table? When scientists were organizing the known elements, they noticed certain patterns of chemical and physical behavior kept repeating themselves over and over. In the very first column or group of the periodic table, we have these elements lithium, sodium, and potassium. They're all in the same column, and they are all very shiny metals that violently react with water, as you can see in the image here. On the opposite end of the periodic table, in the very last column, are these gases: helium, neon, argon, krypton, xenon, and radon. They are all very stable gases, and they're used often in neon lighting, as you can see in the image. The patterns that were noticed in the periodic table were so predictable that Dmitri Mendeleev, the scientist who formulated the periodic law, was actually able to predict the existence of elements 31, gallium, and 32, germanium, and their approximate masses before they were even discovered, based on the existing patterns of known elements. Mendeleev's work preceded the discovery of subatomic particles. As we continue our study and review of the periodic table, you want to make sure you have a copy of one with you to go along with the course. Any copy you prefer is fine. Just do a search on periodic table and numerous versions will appear. If you prefer, you can use the periodic table in this link. Just make sure you keep it handy. Let's talk a little bit about the history of the periodic table. Mendeleev argued that elemental properties, or the properties of the elements in the periodic table, are periodic functions. Remember, periodic just means repetitive functions of their atomic weights. We now know that element properties are periodic functions of their atomic number. So when we list atoms on the periodic table in rows based on their number of protons or their atomic number, we get repetitive patterns in every group. The periodic table is made up of both rows and columns. The rows in the periodic table are called periods. Columns in the periodic table are called groups. Sometimes groups are referred to as families, but groups is more traditional. Here's a visual depiction of the groups and periods on the periodic table. The periods are numbered from 1 to 7. It's the number of rows across. And remember, we get this repetitive pattern with each row. And then the groups are the vertical columns. So we have group 1, group 2, group 3, and over here we have group 16, group 17. There are 18 groups total in the periodic table. Different periodic tables can present more or less information about the elements. The most common pieces of information are shown in the image. The symbol right here, this capital N, is an abbreviation for the element. The first letter is always capitalized. That's why you see a capital N here. If there is a second letter in the abbreviation or the symbol, the second letter is lowercase. Below that, you might see the name of the element. So this capital N here represents the element nitrogen. The atomic number is the whole number that you'll see on a periodic table. And the atomic number is the number of protons in the atom. And then finally, you'll often see what's known as the average atomic mass. This will be the value that's a decimal value on your periodic table. And what it is the average mass of all of the isotopes of this element. Let's talk more specifically about protons now. The number of protons in the nucleus is called the atomic number, and in equations it is designated by the letter Z. The atomic number is always the same for a specific type of element. So if we look more closely at this nitrogen that we saw in the previous slide, if an atom is nitrogen, it will always have 7 protons. And if an element has 7 protons, it must be nitrogen. The name and the number of protons are linked. While the number of protons defines an atom, the number of neutrons in a particular atom can vary. Atoms with the same number of protons but different numbers of neutrons are called isotopes. In order to specify a particular isotope, we use the mass number, which specifies the total number of protons and neutrons in an atom. The mass number is designated by the letter A. The periodic table does not tell you the mass number because it's not a whole number value. What the periodic table tells you is the average mass of all the different isotopes. In order to find the number of neutrons, which we've labeled N, you subtract the number of protons, Z, from the mass number, A, as shown in the equation. To refer to a specific atom, there are a couple of different forms we can use. The first, right here, where X is the element symbol, Z is the number of protons, and A is the mass number, or the protons plus neutrons. Or we might say the element name with a dash and then the mass number following it. So let's look at an example. This is nitrogen N. So is this nitrogen N. Nitrogen by definition has 7 protons. So we have the Z here, 7 protons. And nitrogen has more than one isotope. So one of the isotopes has a mass number of 14, and the other has a mass number of 15. And then you can see if we write it out the long way, we would say nitrogen 14 or nitrogen 15. So they both have 7 protons, but nitrogen 14 has 7 neutrons, and nitrogen 15 has 8 neutrons. These are isotopes of one another. Finally, let's talk about electrons. If an atom is neutral, meaning that it doesn't have an overall charge, then the number of electrons will equal the number of protons. However, atoms can gain or lose electrons and become ions. Ions are atoms that have a charge. Positive ions are cations, and those are atoms that have lost electrons. If you lose electrons, then you have more protons, and that will make you positive. Negative ions are called anions, and those are atoms that have gained electrons or have more electrons than protons, so they have an overall negative charge. The charge of an ion is indicated on the upper right side of an element symbol, not the number of electrons. So we don't show the total number of electrons ever in an element symbol. We only ever show the overall charge of the ion. In order to get the overall charge of the ion, you subtract the positive charge from the negative charge, right? If you subtract the charge from the number of protons, if the atom is positive, that will give you the number of electrons, and add that charge to the number of protons if the atom is negative, meaning that it has more electrons. We'll look at an example of this on the next slide. All right, so let's look more closely at how this charge works. In my experience, this is the part that trips students up the most. So if we look at this first element symbol for nitrogen, this is neutral. We don't see any charge here. We know that this 7 means that it has 7 protons. Because it's neutral, that also means that it has 7 electrons. So 7 protons and 7 electrons. And then, of course, using the mass number, we can say 14 minus 7 equals 7, and that gives us our number of neutrons. Okay, so 7 protons, 7 neutrons, and 7 electrons. But what about this one right here? This has an overall charge of 3 minus. And what that means is it has more negatives, more electrons. How many more? 3 more electrons than protons. So some of this is the same. We still know that there are 7 protons. 14 minus 7 is still 7 neutrons. So 7 protons and 7 neutrons, but 3 additional negatives. So if we started with 7 protons, 3 additional negatives gives us an additional, or a total of, 10 electrons. Okay, so 10 electrons, because we have this -3, or this excess of 3 more negative charges. Let's look at one that has a positive charge, so a cation, right? So magnesium, this is the magnesium ion. It has a charge of +2. The atomic number in the bottom left corner tells us that there are 12 protons. The number of neutrons can be found by taking the mass number 25 minus 12. So we get 13 neutrons. And what this 2 plus means is that it has 2 more positives than negatives. So what that means is if we have 12 positives and there are 2 more positives than negatives, then we are left with 10 electrons. So 12 positives, 10 negatives gives us an overall charge of 2 plus for this magnesium ion. When an atom gains electrons, it becomes negative. So we add to the number of protons to get an overall negative charge. The number of electrons is more than the number of protons. Positive atoms have lost electrons, so you find the number of electrons by subtracting that charge from the number of protons.